All right, today we're going to look at tree views. Tree views are a hierarchical data store, and they will display as a hierarchy on the screen. A subset of tree view would be a list view, which is more of a tabular, non-hierarchical view. So you can actually make a list view out of a tree view just by having no children of any of the elements. What does a tree view looks like? It looks like this. And you'll notice the background here will indicate rows that have been selected. So if I click this little diamond here, you see it shows me a child row. Notice the child row has no diamond because it has no descendants. Alternatively, here in row 2, if I click on the diamond, it's got 3 levels of depth. Now, at the 3rd level, or any of these levels, it could be multiple lines. I just have the simplest possibility. So row 2 is a 3-level hierarchy: the top level, middle level, and bottom level. Row 1 is a 2-level hierarchy, and I could have a row which has no descendants. But anyway, when I click these things, you can see the background changing, indicating that it knows I'm doing it. The column headings up here are just generic. I didn't mean them to be anything specific. All right, how do we do this? These are very handy. They are, they're very useful for things, and the contents here don't necessarily have to be text, although normally they are. And you don't have to have 2 things. It could just be one thing. It didn't have to be 2 columns. Only 1 column was necessary. It could have more than 1 column. All right. Let's look at the Glade file. The Glade file, first of all, we've got a tree store, which is the data structure that's going to hold things. And the tree store I've named tree store. It's a Gtk tree store, so I gave it a simple name. And it's got 2 columns defined. They're named C1 and C2. And if you click this button here, it'll go through the definition situation, and you tell it what type of data it's going to hold. Character array is most common. Boolean might be another, but anyway, I don't want. I guess it's defining a column. I didn't want that. Okay, so I've got 2 columns, 2 character array columns. That's all I need to say. There's no packing. There's no common. There are some signals because you could conceivably change these values, and you might want to detect them. And anyway, the GTK store is not part of anything, although it was at the top. It suddenly has migrated down to the bottom, but it'll go back up to the top because it's not really part of the window. It's kind of independent of everybody. It's data structure. All right, at the top we've got our window, same as before. It's called, I assume, window. We got a fixed grid at the next level, pretty normal. I've got a viewport. I have to have a viewport to put the tree view in. There could be a scrolled window here, which I will use in the next example, but here's just a plain old simple viewport. And it's got a location, and it's got a size, 408 by 303. That's its size. I'm not picking up any signals from it, so it's just pretty much a garden variety viewport. In the viewport is a Gtk tree view. Okay? And where do you find the tree view? Tree view, the others we've done, okay? The tree view is a display item, and there it is, tree view, all right? And I dragged it over into the viewport, and so that's how I got my tree view. The tree view I've named TV1. I haven't been very clever with names, just keep them small. So that's the name of it. Packing, it has none because it's contained in the viewport. I didn't change anything down here. And the signals, there are no signals at this level, but there will be further down. So in the tree view, I have other things. When you take a tree view, you're automatically going to get a Gtk Tree Selection. It's part of it. You're going to get one whether you like it or not. In the selection, I gave it the name Select. It's going to point to the row that's been selected. When you click on a row or select a row, this is where it's going to come from. It has a signal. I think it's the only signal I actually detect here. On select changed. If select moves to another row, this is the signal that's going to be activated. Okay, so so that automatically is in there. Now this is a column, and the column contains a renderer for text. That's the thing that actually creates the text on the screen or in the column. It could be something other than text. It could be something that creates a progress bar. There's other possibilities in here. This is another row. This is and then notice the name CX1, CX2 of the row, and the renderers are CR1 and CR2. Okay, it gets a little confusing, but that's all there are. So nonetheless, so I've got two rows, and I've got two sets of renderers. Now, how did I get these? Well, you can click just about anywhere, but the trick is you right-click and you say Edit, and that brings stuff up. Okay, so if I go to column 1, in column 1 here, and knowing that that's where it is, there's the title. That's the thing that's going to appear across the top of the screen. I notice it says column 1. There's nothing. I didn't change anything here. This is just the default for the column. Other than give it a name, CX1. Then in the column, again, I'm going to right-click on the column. This is all right-click stuff. So add something, and I added child text. I'm not going to do it because it's already here, and that gives me the renderer. You see, it's a cell renderer. It shows up as text, but it's a cell renderer for text, and I gave it the name CR1. I didn't change any of these guys. Okay, they're all the same. Some of these are deprecated because of version differences. You'll see a lot of these little things pop up. They're not harmful, but anyway, they're there. Likewise, on this guy here, I right-clicked and I did an add. You see other things you can add, like a combo box, a spin, picture, progress bar, toggle. So what I did is I added for each of these two columns. First of all, I added the two columns, and then in each of the columns, I added text as a dependent. That's what the column's going to contain. I guess a column can contain more than one thing. I have not tried. But anyway, normally it's just going to be text in most applications. So that's how I got the columns defined, is by right-clicking up here and then adding the columns, then in the columns adding the appropriate renderer for text. That's all we're doing is just text. So that's it. That's everything to give you what you see here. Don't worry about the fact that these are the column headings I gave it. They're just arbitrary sizes. They'll sort themselves out later. All right. So remember the names: window, fixed one, view one. They're the same as we used before. The tree view is TV1. The selector is called select. Then we got CX1 and CX2 for the rows, CR1 and CR2 for the renderers. And tree store is the tree store. All right, let's go look at the code. The code is a lot of it's very similar. Is that there's the window, there's the fix, there's the view one. Then I started using their real names here because some of the casting from widget gives you error messages. So tree store is a tree store and so forth. So I've used their correct names: tree view column. Tree view selection, GTK cell renderer. I guess they're used in more than just tree views. And finally, the builder. Everything's the same that we've done before until we get down here, and I pull them out. Now over here, instead of saying widget for everything, I've gone to the casting for their actual type: tree store, tree view. Tree view column and so forth. There's the tree view, two columns, two renderers, and the selection. So there's the pointers that will be used shortly. All right, next thing we got to do is we got to add the renderers to the columns. I can't get it to happen automatically. There may be some way of doing it, but here's how you add the renderers. Column 1, CX1, gets renderer 1, and you tell it it's for text. And you tell it that it's, again, the first column, column 0. Likewise, you do for column 2. You insert CR2, the renderer. You tell it it's text, and you tell it it's the second column, column 1. Okay, so now the renderers have been added. The renderers are actually going to make things appear in the columns. Since different types of things can appear in the columns, you have to have different renderers. Then I've got 3 iterators declared. iter child 1, and iter child 2. Now to add rows to the tree store is fairly simple if you do it right. It's completely impossible if you do it wrong, but anyway. First of all, I call tree store append, and I pass down tree store, and I pass down the address. Notice the ampersand. The address of iter. Notice iter is not a pointer. Iter is probably a structure. I don't know. But I'm passing down the address of iter, ampersand iter. And the null means there's no parent. We'll see that in a second. I pass down iter, and it sets iter to be the address of the next row in the tree store. There's append, there's prepend, there's a whole bunch of others, but I'm adding them one after another. It's probably the most common. Certainly one of the simple ones. Okay, iter comes back and it's pointing to a row. Now I'm going to put the stuff in the row. Now this could all be done on one line, but I've done it on 2 lines. I'm only adding 2 things. It's column 1 and column 2. It's not a lot. So I tell it its tree store. I give it the iter, which is basically the iterator to the row. I tell it it's the first column, column 0, and I tell it the contents. I want the text row 1 to appear here. I could have said fluffy. I mean, this is the text that will actually appear there. And the -1 means this is all there is here. I could add the entire row on this one command by just now repeating the last 2 items, but I'm doing them one at a time. So the -1 just means there's no more on this line. The second line down here is I'm adding the second part, the column 2, or column 1, if 0 and 1 are the 2 actual column names, and it's going to be row 1 data, and again the -1 means that's all there is. So that added the first row. All right, this adds the child of the first row. Remember, the first row had a child. You don't have to have a child, but I did. Now I go down to the append guy, and I tell it I want an iterator, child 1, iter child 1. And its parent is going to be the row pointed to, figuratively, by iter. Iter is, of course, still pointing, still addressing, I think is probably a better word, the first row, the one I just did. So the one I just did, and that's the parent row. This is the parent position. This is the child. So it's going to give me the next row underneath the parent, as it turns out, because the parent was the previous one. This is append, and it gives me an iterator to this next row. And in this next row, I put in row 1 child and row 1 child data. These are this will be a row of its own, but it'll be a dependent row of the parent row pointed to by or referenced by this iter. Okay, which was this row up here. So there I have a descendant row. Let's look at the code. Do I have it running someplace? No, I killed it. Okay, bring it up again and look at it. There's row 1 and row 1 data, and you can see the triangle here means it's got a descendant. If it didn't have a descendant, there'd be no triangle. Here is the descendant. You notice the descendant doesn't have a triangle because the descendant that's it. There's no more. There could be multiple rows here. It's not, everything doesn't have to be a single thing or a single thing with a dependent. There could be several items at this level. All right, so, and you notice every time I click it, of course, this thing up here changes, indicating that's the selection. That's the selection. When I click from that, the selection is changing, and it's telling me about it. This row here, which you're about to do, it has a child, like the previous row, but the child has a child. This goes down 3 levels of depth, 1, 2, 3. All right, and so let's go back to here and get that off the screen. So now we go back up to the top. We're back up to iter. We ask for the next row relative to the original row up above, and it gives us the reference to it. And I add row 2 and row 2 data. Okay, that's these. And that would be the second row at the top level. All right, then I do the same thing for a child, where iter is the second row of the top level, and I'm going to get the reference to a child. And I put in row 2 child and row 2 data. All right, now I'm going to do the third level. At the third level, I get the reference to the next available row, as it turns out. I get a reference to that, which is dependent on the previous row, which is the second level row of row. There's row 2, there's row 2's child, and this is row 2's child's child that I'm building here. And I put in row 2 child of child, row 2 child of child data. So this adds the third level, and we're off to the races. Next thing I do, so you build your data before, well, you can build it dynamically, but I think in most cases you'll probably build your table before you start up the actual graphical display. However, you can dynamically edit these displays in real time while the GUI is running. All right, I pull out the address of the selector. Okay, this is the pointer to selection is a pointer, and it's going to give me a pointer to the selection associated with TV1. TV1 being my my tree view. Then I show all, it shows window and all its dependents. And I start GTK main, and that will run until we terminate. Then we'll exit altogether. All right, this is where we get. This is the signal handler for a change in the selection. If the selection changes, we'll go here. And I've got a couple of things declared. I've got a character string pointer. I've got an iterator, and I've got a pointer to tree model, which is basically it's the it's going to be the tree store. Okay, Gtk Tree Selected Get Selected, and I pass down the tree selector here, which tells us where we are. I pass down the address of the model. This fills in the model associated with the selector here. C being the pointer that came in as a widget, which is the selector, of course, Gtk Tree Selection. You see the cast, and we get an iterator to the row in the model that's being referenced. If it comes back false, it means there is no selection. Apparently, you can enter this in debugging situations. So if it's false, you just plain return. If it's not false, you fall through. If it's not false, model has been filled in and iter has been filled in by this function. Anyway, so we get down here, Gtk Tree Get Model, and we pass down the model, we pass down the iterator, and we specify column 0, and we get a value. Value being a pointer to a character string a few lines up above, if you notice. And we could get more than one thing again. But I'm just getting one value I'm getting the pointer to the value in column 0 of the selected row. All right, and I print it out. Column 0 equals %S semicolon. Notice no new line, and there's the pointer value to the character string. And then I do it again. This time I ask for the value from column 1 of the selected row. And it comes back, and I say column 1 equals %S, there's value, and there's the new line character. So that's why you see it all on one line. So that's how it works. It's a fairly simple example, but it does everything you really want to do. You create a row, you can create children of rows, you can create children of children. You're going to need a lot, more and more iterators as you do this. But in the net effect, of course, is to give you something that looks like this. And again, this is just in a basic viewport. If you're going to have a whole lot of these things, you would probably have a scrolled window, not a basic viewport. And we'll do that in the next example. And every time you click here, you can see the selector is generating a signal that goes down to this final program here. And there you are. And you can put anything in here you want. I've used 2 columns. There's a lot. Most of the examples you're going to see are going to be just a single column. For example, the top level might be, classes, or say a department, and the second level might be the top level would be a single column, and the contents would be department names, academic department names. The second level would have a single column, and it would have the courses for a given department, and so forth and so on. And within a course, it could be the instructor, and so. But it's only one column at each level. The meaning of that column changes as you drop from one level to the next, but it doesn't have to have the same meaning. That column can at one level be a name of a department, at the next level be the course name, at the next level be the instructor name, and so forth and so on. So I've used 2 columns here because I felt like it. All right, the next example will be much more complicated, but same basic idea. I didn't want to do a more complicated example because the simple one is all you need to get started, and you can make the simple one complicated as anytime you want to. All right.